Okay, guys, let us go for the 2014 question, right? So this is the 2014 A-level question, right? So 2014 A-level question, the 12th question, right? A part, right? The A part of the 12th question. So if you see this, actually this is a relative acceleration problem related with wedges, right? So when considering relative acceleration problems, you can get either a pulley question or else a wedges question. So this is a complete wedge problem, right? Let's see what they are saying. Okay, so the triangle ABC in the given figure represents a vertical cross section through the center of gravity of a uniform smooth wedge of mass m. The mass of this wedge is capital M, right? Then the line AB is the line of the greater slope of the face containing it. ABC is alpha, and this is alpha. ACB is 90. ACB is 90 degrees. This is 90 degrees, and BC is equal to A. Okay, the wedge is placed with the face containing BC on a smooth horizontal flow. This flow is smooth, right? Which means what? If it is smooth, then that means there is going to be any sort of friction involved, right? So okay, a particle of mass simple m, this is of mass simple m, is placed gently on the line AB at A and released from rest. It's initially released from rest. So show that until the particle leaves the wedge, the acceleration of the wedge is much. Simply what they're saying is, until the particle is in contact with the wedge, show that the acceleration of the wedge is this much. So simply, first of all, let us find that. So we will have to go for the diagram, and we'll have to mark first of all the possible forces, right? That's what we do as the initial step. Okay, it's going to have a weight capital Mg, and then it's going to have a reaction capital S perpendicular. This is 90 degrees. What else? Okay, this guy is going to have its weight acting downwards Mg, and then there's going to be a reaction acting on the particle by the wedge, and a reaction on the wedge by the particle, right? Cool. These are the only possible forces acting on this wedge. Okay, so next what we need to mark is simply the accelerations of the objects, right? So if we consider, let's assume the acceleration of the wedge is in this direction. So acceleration of the wedge relative to earth, right? It's relative to earth. In this direction, it's A, because the wedge is on the earth, on the ground. So therefore the acceleration of the wedge relative to earth is A. So now let us consider the acceleration of the simple m particle is A dash, right? So what is it? The acceleration of the particle relative to the wedge, because the particle lies on the wedge and it is in this direction, alpha inclined A dash. But what we need is the acceleration of the particle relative to earth. Acceleration of the particle relative to earth. How do we get it? Acceleration of the particle relative to the wedge plus acceleration of the wedge relative to the earth. This is the equation. So what is the acceleration of the particle relative to earth? It is A dash. In this direction, alpha A dash. What is the acceleration of the wedge relative to earth? It's in this direction, A. Right. Okay, good. Let's move on to the next part. Next, what do we have to do? Simply we will have to find this A, right? This is the acceleration of the wedge relative to earth. That is what they are asking us to find an expression for A. So simply guys, we need to apply F equals ma to each of these objects in the direction of its motion, right? So first of all, I will consider the particle and apply F equals ma along the plane along AB, right? So for the particle simple m, I'm going to apply F equals ma along the plane, right? So what will be the what will be the force acting on the particle? So if you see, guys, this is alpha, which means this is alpha, right? Which means the force in this direction is mg sine alpha, right? So that is the only force acting along the plane. R is perpendicular to this direction, so therefore R will not come into the equation. Only mg sine alpha will be acting along the plane. Mg sine alpha, isn't it? Mg sine alpha. What is the mass? M. So what is the acceleration of the particle? Acceleration of the particle relative to Earth in this direction along the plane. Along the plane, acceleration a dash is there, and if you consider this is alpha. A cos alpha is in the upward direction, so therefore it is minus a cos alpha, right? So if you see, guys, m to m cancels out. G sine alpha is equal to a dash minus a cos alpha, right? So from here what we need to find is a. So therefore let us subject a dash and eliminate it. G sine alpha plus a cos alpha. Okay, this is the first equation. Now let us go for the next equation. Actually there's two unknown parameters, a dash and a. So therefore we need two equations to get the answer. So therefore for the complete system, I'm going to apply F equals ma in the horizontal direction for the complete system, right? Yes. Okay, so let us apply for the system F equals ma in the horizontal direction. So if we consider what is the force acting in the horizontal direction in the system, so when we consider the system, guys, you need to consider all of these, right? So okay, so is there any horizontal force? R to R cancels, internal forces, mg downwards, s upwards. No horizontal force, therefore it's going to be 0, isn't it? It's going to be 0. So, and then you need to write the MA products of each and every object. So let us consider the wedge first. The mass of the wedge is A. What is the acceleration of the wedge relative to Earth in this direction? It's simple, A, isn't it? Acceleration of the wedge relative to Earth, this direction is simple A. So the next particle is simple M. The mass is simple M. What is the acceleration of simple M particle in the horizontal direction? In the horizontal direction, A minus A, there is a component of A dash, right? A dash, if you take the horizontal component of A dash, it is going to be A dash cos alpha. A dash cos alpha in this direction. So A minus A dash cos alpha, right? So here let us subject ma plus simple ma minus ma dash cos alpha, right? Let's take a out, capital M plus simple M. We simplify m cos alpha a dash. Instead of a dash, I'm going to write this g sine alpha plus a cos alpha. All right. So further I will simplify this. A capital M plus simple M, mg sine alpha cos alpha plus ma cos squared alpha. Take it to this side. A, if you take it inside, m 1 minus cos squared alpha, like when you take this into inside and then when you take m out, is equal to mg sine alpha cos alpha, right? And if you subject A, you are going to get A is equal to mg sine alpha cos alpha over capital M plus simple M. 1 minus cos squared alpha is sine squared alpha, right? So this is the answer, I guess, right? So yeah, this is what they are asking us to find. And find the, and okay, that's done, right? This is done. Find the acceleration of the particle relative to the wedge as well. We need to find the acceleration of the particle relative to the wedge also, which means we need to find a dash. We need to find a dash. How are we going to find a dash? We can find a dash easily. A dash is equal to what? A dash is equal to g sin alpha plus a cos alpha, isn't it? A cos alpha, right? Yeah, it's a cos alpha, but we know a. We know what a is, right? It is mg sin alpha cos alpha, right? Capital M plus M sin squared alpha, right? So if you simplify this, a dash is going to be capital Mg sin alpha plus Mg sin cube alpha plus Mg sin alpha cos squared alpha over capital M plus simple M sin. Okay, a dash in that case is going to be Mg sin alpha, right? And Mg sin cube alpha plus Mg. This of course I can write it as 1 minus sine squared alpha, right? So this I can write it as 1 minus sine squared alpha. So then mg sine alpha into 1 is mg sine alpha. Mg sine alpha into minus sine squared alpha is mg sine cube alpha divided by capital M plus M sine squared alpha. This to this cancels out, right? So a dash is equal to M plus simple M g sin alpha over M plus M sin squared alpha, right? So this is the acceleration for the relative so this is the acceleration of the particle. All right, okay, cool, fine. So what do they ask next? Now suppose alpha is pi over 4, capital M is m over 2. Show that the speed of the wedge at the instance when the particle leaves the wedge is this much. So they have given a value, guys, right? They have given a value to the alpha and another value for the capital M in terms of simple M, right? And then they are saying show that the speed of the wedge at the instance when the particle leaves the wedge is this much. Okay, we need to first of all find what is the time taken by the particle to reach the bottom, right? If it started at equal 0, we need to find what was the time taken by the particle to reach the bottom. At that time, right, when the particle reached the bottom, let us assume the time taken is simple t. We need to find within simple t time, after simple t time, what is the velocity of the wedge? After simple t time, what is the velocity of the wedge, right? So first of all, let us find this time, right? So if this is a, this is alpha, this is 90, we can get x. Let's assume the distance is ab. So we can get ab easily, the distance ab easily, right? So okay, it's like this, right? A, b, this is alpha, this is 90. We need to get ab. Let's assume this is x, this is a, right? So in that case, we can use what? Cos alpha. Cos alpha is adjacent over hypotenuse. X is equal to a over cos alpha, right? Okay, so for the particle symbol m in the ab direction, right, in the ab direction, we know that the initial velocity of the particle was 0, right? We know the displacement of the particle. It has to travel a over cos alpha distance to reach the bottom. We know the acceleration of the particle is a dash, right? So we will what we need to find is t, right? So what we are going to do in that case is from A to B we are going to apply v equal u plus at in this direction. Not v equal u plus at, because we do not know the final velocity, right? So we will apply maybe s equals ut plus half at squared. What is s? S is a over cos alpha. Ut, this is 0, initial velocity is 0, half into what is the acceleration? A dash. What is A dash? A dash we found m, capital M plus, okay, let's assume A dash is A dash, t squared. So t squared is equal to 2a over A dash cos alpha. If you substitute A dash, you will get t to be something. So if you see guys, if you apply alpha is equal to pi over 4, right? Alpha is equal to pi over 4, pi over 4, and then capital M is equal to 5m over 2. Then of course you will be getting this. If you simplify A dash, you need to apply the acceleration of the particle relative to the wedge, right? So this, when you apply all these values and if you simplify, you're going to get the time to be as 24a over 7g. So this is the time taken by the particle. This is the time taken by the particle to travel from A to B. The time taken by the particle to travel this distance. So when the particle travels this distance, the wedge will travel a certain distance in this side, right? So the particle takes t amount of time to reach here. We need to find what is the velocity of the wedge within that t time, right? Initially it was 0. Within that t time, what is the velocity that it acquires, right? So for the velocity for the wedge, therefore I'm gonna write, okay, for the wedge in this direction we are going to write v equal u plus at, right? V is what we need to find. U is the initial velocity, that is 0. A is the acceleration of the wedge. T is this time. This is the time t. So V is 0 plus A. A. A, you know what it is, right? A means the acceleration of the wedge, right? This is acceleration of the wedge. So 24 A over G. This A is a distance, this distance. I do not mix up, right? I shouldn't have taken the same symbols, right? So this is A. I should have taken this as maybe capital F and this is simple F, but it doesn't matter. Do not mix up, right? So do not get confused. So if you apply the acceleration of the wedge here, we have found it. Where is it? Acceleration of the wedge we have found. So in each of these places you need to apply pi over 4, and this capital M you need to apply 5m over 2. Here pi over 4, you will get a simplified answer such that this is going to be g over 6 or something, right? So this is going to be, if you simplify this, you are going to get this as g over 6. So if you substitute g over 6 here, if you substitute simply, let me once again rewrite it, maybe, right? 24 over 7. So for the wedge, we are going to write in this direction v equal u plus at. V is what we need to find. The initial velocity is 0. So this is g over 6. What is the time? 24a over 7, right? 24a over 7. So if you simplify this, of course, you are going to get the final velocity of the wedge to be as 2GA over 21. So this is it for the discussion of the 2014 problem, guys, right? So yeah, so hope you understood this. So let us